Boom, we're recording. Okay, welcome everyone. So today I am delighted to introduce Mark McQuaid from Annika. Mark is a data science and engineering practice manager with specific expertise in the AI and machine learning discipline, creating and building proof of concept solutions, end-to-end solutions, scaling model deployment, and everything in between, especially with experience on the AWS stack. Now, Mark is a pretty humble guy, so one thing he won't tell you that I will tell you is that AWS maintains records on the most active advocates in the AWS ecosystem, and Mark is currently number 3 in all of North America. In fact, he's doing I don't know what it is, Mark, if you're doing, 5 events in the next 2 weeks to take number 1, but he's joining us hot off a podcast doing this webinar, and he's got a couple more webinars in this single week. I mean, you are learning from the best here today. So we are eager to have Mark's commentary, and I'll let Mark provide additional commentary. But the last thing I will note is just for the benefits of the recording, Joseph Nelson, co-founder, CEO of Roboflow. I can be reached joseph.nelson@roboflow.ai with any questions around computer vision, around using Roboflow, and we'll jump into a formal Q&A session at the end. The other thing I want to note is I am moderating the chat throughout the session. That means drop your questions in. The benefit of joining us live rather than seeing the recording is you get to tailor the content to your interests. So if there's an area where you want us to dive deeper, if you want us to say, hey, why did you do that step? Or, hey, I have this kind of question specific to my problem, throw them in the chat. At worst, we will say those are going to be held for the formal Q&A. And at best, we will be able to tailor today's content to go deeper in the areas that you want to hear about. So please do continue to be active in the chat throughout. I sure will be. And I'm going to kick it over to Mark to begin to actually kick off the session. Mark, please take it away.
Thanks, Joseph. I appreciate that. Those were some kind words. Yeah, I'm pretty busy right now with talks, events, webinars. I've probably overcommitted myself a little bit over the next few weeks, but that's okay. I'll get through it. I enjoy doing it. So yeah, and thanks everyone for joining today's session and taking the time out of your day. We're talking today about applied object detection. So building a custom computer vision model, specifically in regards to face mask detection. My name is Mark McQuaid. Little intro. Joseph already did a better job than I could ever do, but my name is Mark McQuaid. I'm a practice manager at Annika within our data science and engineering practice. Within the data science and engineering practice, we focus on all things AI, ML, and all things data. So the agenda for today's talk, okay, so introductions, which we've done. Then we'll go through an introduction to computer vision problems, use cases. Then we'll talk about kind of the pipeline, the flow, right? Data collection, which includes data labeling, pre-processing. We'll talk a little bit about augmentation. Then we'll get into training that model. Then inference. We'll see what it is live and in action, and then we'll get into a Q&A. So with that, I'd like to briefly introduce you to the portfolio of offerings that Annika itself delivers. So as you can see on the screen here, the Elevate category is all about adopting the cloud and improving your current infrastructure and processes within the cloud. And that includes such things as cloud adoption and data engineering. Then you see the Operate category that focuses on helping you run production environments, right? Optimizing those environments and of course, securing them as well. So that could include things like managed services, managed cloud operations, and cost optimization. Then you see the Innovate category. So that's all about building, right? So that's new capabilities, new innovation, and new technology that can propel your business forward. So this is your AI, your ML, and your IoT, right? So this is what today's talk would fall in the Innovate category. So a little bit more about Annika, all in APN Premier Consulting Partner. So all in meaning AWS exclusive, 100% focus on helping customers be successful within the AWS cloud. We feel we've developed a certain mastery of the platform and strategically chose to do that with AWS based on the breadth of services from within. Cloud native thinking, right? Everything we do is cloud native first and foremost, delivering results that leverage the full power of the cloud. outcomes designed to last. So we ensure the cloud keeps delivering value without rework, of course, long after we've wrapped up an engagement. And we're all about the people, right? So we approach all our projects very collaboratively, which allows the teams we work with to gain new skills, and they can continue down that path to success that we've built together. As you can see on the right too, it shows some of our AWS competencies. And one I wanted to point out is our machine learning competency. I believe it's our newest competency. It's fairly new for us, but we're really proud of that one because only 26 partners in the world have the machine learning competency. So yeah, something we're really proud of that I like to point out. And something else we're proud of is the 1,600 plus AWS certifications in-house, right? So that speaks to the skill set that we have in-house. Okay, now a little bit about Roboflow. So, Roboflow accelerates computer vision development, right? So Roboflow is a product, right, that enables developers to use computer vision without being machine learning experts, right? So it kind of goes hand in hand with, if anyone knows the AWS AI services, that top layer stack in the AWS ML stack, that's AWS's model, right? That's, trying to put machine learning in the hands of all developers. And that's, Roboflow's got, that's what Roboflow is trying to accomplish as well, right? So over 6,000 developers from Fortune 500 and startups alike use Roboflow to solve their problems with computer vision. So today we'll make use of Roboflow's tool for improving and managing our image data, and they're an Aunica partner as well. All right, so now we'll get into an overview. So today, we're going to train an object detection model from scratch to identify the presence of face masks, right? Obviously extremely important today in the world we live in, who's wearing masks, or, who's not wearing a mask. So we figured it'd be a perfect use case for this webinar. So we'll talk a bit about, computer vision in general as well, and the different use cases, and see, how it can benefit your specific industry or your domain. But it can be used for many things now, right? Computer vision is actually, can be widely used in a wide variety of things. So as you can see here, computer vision is improving every industry. So touching on what I just mentioned. So as you can see, all these things on the screen here. So I'll just mention a few, right? So hard hat detection, right? That's a big one. So construction sites, right? Needing to ensure workplace safety. You need to know if someone's wearing a hard hat or if they're not wearing a hard hat, right? Perfect use case for computer vision. Plant versus weed detection. So using drone imagery to identify which plants are weeds targeted for herbicide use, right? Satellite imagery. So maybe identifying HVAC units on rooftops to determine lead energy efficiency. So I won't go into all these. As you can see, there's plenty of them, and I'm sure everyone on this call has heard of a wide variety of other use cases. And on the next few slides, I'll just touch on some more a little deeper. So aerial imagery. So if you can see the photo here, using computer vision to identify boats, boat lifts, and homes on a lake, right, from a drone, in order to ensure compliance, right, with the lake, right? Whatever compliance that may be with the lake, you have the ability to ensure that compliance is being met using aerial imagery. Cell counting, right? So using computer vision to determine the outputs of laboratory experiments to automatically identify and count cell populations. And what we're doing today, mask detection. So using computer vision to determine if an individual is wearing a mask or not wearing a mask, right? Extremely important in the world we live in today. So what is computer vision, right? So computer vision, I'm sure you've all heard of it, but computer vision is teaching computers to see images like humans can, if not better. So an official definition of computer vision is computer vision is a field of artificial intelligence that trains computers to interpret and understand the visual world, right? Using digital images from cameras and videos, and use deep learning or machine learning models that can accurately identify and classify objects, and then react to what they see based on that. So, as you can see more precisely, processing and deriving inference from an image and video data. So, I mean, it's pretty, self-explanatory what you're trying to do. Under the hood, it's pretty complex though, right? So here is just a look at what some computer vision problem types, right? Computer vision itself has many kind of, factions to it. So you have classification, right? So that's image level thing labeler, right? So this is a cat. I'm sure everyone's heard of that. Classification plus localization, right? So that's a thing labeler plus position of the thing. So there's a cat in this image and it is in the center of the image, okay? Object detection, which is what we're doing today. Identify multiple types of things and where they are in the image. Semantic segmentation is another one. Identify precisely what is in my image and the shapes of where they are. And if you can see at the bottom, there's a couple other that aren't mentioned that are pretty cool. Key point detection, right? So it gives you the ability to identify joints, right? So you could look at potentially what a successful golf swing could look like, right? By doing key point detection. Or pose detection, which is actually a form of key point detection, right? So that's identifying the position of an individual's body, right? So one use case that is kind of, you know, what I've heard is out there, or I've seen. If you've ever seen in the NFL, you know, you can actually do key point detection on, you know, the line of scrimmage and all the players, you know, on offense, or to see if you know, what play they may run, right? The way they're positioned, they can do key point detection. Then you can predict what play they're going to run, right? So really cool things happening with key point detection. All right, so now we'll get into the end-to-end overview. So we're going to train, as I said today, an object detection model from scratch, right? So solving a computer vision problem relies on these 7 steps, right? So you have defining your problem, right? So, you know, what are you trying to accomplish, right? So in the case of today, we're doing object detection. We're trying to say, you know, is there a mask in processing? Then we get into augmentation. Then we get into the training, right? Building that model, and then we get into inference, right? So be able to hit that trained model and actually see some value. So what steps do we follow to complete a computer vision problem? This slide's just kind of further to what we mentioned, just in a visual, right? So you have your problem statement. What are you trying to do? What is the use case? You're going to collect all that data, collect all those images or videos. Then you're going to prepare that data. You're going to train a model, and then you're going to pump it out for inference. Okay, so tools we'll use today. So industry-leading tools, right? So what we're going to use specifically, obviously, is Roboflow, which I'll get into a little bit more on what that looks like during the demo. But you know that we're going to use Roboflow to organize and manage the data sets. SageMaker Ground Truth, for anyone who doesn't know what that is, SageMaker Ground Truth is a fully managed data labeling service that makes it easy to build highly accurate training data sets for machine learning. Right, so you can get started with labeling your data in minutes through the SageMaker Ground Truth console within the AWS console, and you can use custom or built-in data labeling workflows. And then there's AWS Rekognition custom labels. So that's what we're using today. Rekognition itself is one of those AI services that I mentioned earlier, part of that suite of AI services in AWS. It is you know, essentially a service for computer vision, but it's kind of limited. You know, you have the ability to, with Rekognition, identify maybe certain objects or people or text or scenes in an image or video. But you know, it doesn't give you the ability to kind of use domain-specific stuff. So that's where, you know, bring in AWS Rekognition custom labels, which is a fairly new service. So you can identify the objects and scenes and images that are specific to your business needs with custom labels, right? So for example, you can find your logo in a social media post, right? Or identify your products on a store shelf. You know, classify machine parts in an assembly line, or even, you know, detect animated characters in videos. So here's the process. So as you can see, it starts with collection, right? So you're gonna get images, get video, whatever that looks like. That's your collection piece. Then you're gonna go into labeling, right? So you want to, you know, say what you want the computer to learn, right? So you have to label those videos or images accordingly. And then you get into organizing, right? So ensuring that the data is representative and it is of high quality, okay? Pre-processing. So that's raw images, taking those to images that the model, your machine learning model, will understand, okay? Training, right? So you're going to train an ML model. Then you're going to deploy it, right? You're going to use the model, and then you're going to display the model, right? So display the results, interpreting business value from that. And as you can see in this slide, right, you have some examples of things that can be used at each point in the workflow. And as you can see from the label, organize, and process, that's where Roboflow falls in. That's what they, their platform is able to accomplish. And you also have, AWS in there. That's where, the labeling piece comes, ground truth. And then, from a train and deploy standpoint, you have, specifically today we're doing Rekognition, but I mean, you're talking TensorFlow, PyTorch, that could be a variety of things. So this is kind of just what that flow looks like in a visual. All right, so I'll get a little deeper into data collection and labeling right now. So what are important considerations in collecting data, right? So you need images to be representative, for example, right? It has to be representative of the problem you're solving. So for example, if you're aiming to build a face mask detector like we are, we need to consider multiple mask types, right? Some settings where our individuals may be wearing masks, brightness, the condition the photo was taken in, right? Things like that, right? So other considerations could be device type, what's taking the photo or video, the location, the lighting, of course, the angle of that photo, clear process, reproducible. So a lot of things you have to factor into that data collection piece. So if you see here, this is just an example of data collection. So what you have to look for. So varied images across settings, right? So you want to gather varied images. So as you can see in these images, you have, a person with a mask singly, then you have a couple people with masks, maybe a different kind of mask. It's not always, the similar, standard face mask. Then you have, someone not wearing a mask in one of the images. Then you have a ton of people wearing masks. So you want to get that varied amount of images for your model to learn. Now some labeling considerations. So there are dozens of different image annotation formats, right? So, image labels come in all shapes and sizes, right? You have, some popular annotations like Pascal VOC, Pascal VOC, or Coco JSON, create a ML, right? YOLO text, right? And so if you've ever worked with YOLO, if you've ever worked with any of those, you'll know that they, a lot of them require their own, right? So model frameworks expect kind of their own types of annotations at times, right? So TensorFlow expects TF records, right? The Rekognition service expects a manifest.json file, which is a specific to AWS annotation, right? So extracting, transforming, and loading for computer vision is painstaking, right? And as you can see, some of the more popular conversions in this slide, right? So converting Coco to Pascal, or converting Pascal to Coco, right? Or converting Pascal to TensorFlow, to TF records, right? So, it's the annotations, but it also depending on what framework you're going to use to train your model. So getting data labeled with SageMaker Ground Truth, which is what we did today, right? So, SageMaker Ground Truth, right? It kind of has a workflow of its own, right? So you input raw data into S3, you submit a labeling job, you choose from a different group of labelers, right? So this is human labelers, right? Assistive labeling is involved at that point. Labelers use a labeler UI. Then you get your labeled training data set, right? So it's always best to provide clear instructions so the labelers are performing the task as accurately as possible. So that's why you see here, provide clear instructions. So it's a pretty simple process to go about it. It's just, make sure you're providing those clear instructions. And here's just a screenshot of what it looks like within SageMaker Ground Truth. So you can select the task type, right? So it is just showing, you can do bounding boxes for object detection, or you could do image classification, right? Basketball, soccer. This is the interface. So what you do is you start the job, right? The allocation for the job to get picked up and then get the results back could be about a day. And you set a price for that. And results are completed based on the competitiveness of the price you give to do the work, to do the labeling of your images. Okay, so on to data pre-processing. So some considerations of that, image processing are the steps taken to format images before they are used for the model training and inference. So this includes things like resizing, orienting, the color corrections, right? So ensuring data is formatted correctly for the model is key, and that's this step. So for example, how should you resize your data? Often we need our images to be square for the model. Should we preserve aspect ratio? How should we fill in the empty space, right? Should you add some black pixels, white pixels, and so on? Removing EXIF data. So EXIF data is the metadata that the images have from the device that captures it. So generally you want to remove this from your images for computer vision, as EXIF data can confuse the model, right? So all things that you have to account for. Some color changes, right? Do you need to change the color? Does it need to go to grayscale? Do you need to add contrast, right? All things to consider. Now, speaking specifically of this is an example of grayscale. So you may want grayscale for all your images if you want your model to be insensitive to color, right? So grayscale causes the model to be insensitive to the color changes. It may be useful for our mask example. You may not want the model to learn that a mask is blue or a mask is green, because if it's trying to inference off of someone wearing a yellow mask, it might not know what it is. So this could be a good example for grayscale. It would not be useful for something like a self-driving car, where it might need to know the yellow lines versus the white lines, right? Okay, now on to augmentation. So some considerations for augmentation. So image augmentations are manipulations applied to images to create different versions of similar content in order to expose the model to a wider array of training examples. So data augmentation is effectively creating new images, but simulating different conditions, okay? So for example, our individuals wearing masks may be in different lighting conditions. So instead of having to actually take photos of different lighting conditions with people wearing masks, you can use augmentation to simulate room lighting, right? It could be higher, lower, right? You could add some filters, whatever that is. So some other examples, flipping the image, rotating, distorting, adding some blur and noise, all popular forms of data augmentation. So here's an example of an augmentation, a cutout, right? So for example, you may want to teach the model to be insensitive occlusion, right? When an image has objects blocking it from the view of camera. So imagine an individual is walking in front of a camera, partially blocking objects from view. You still want to identify partial face masks, right? So the cutout allows you to do that, right? It allows your model to learn better. So pre-processing versus augmentation, what's the difference? This is a common thing, right? This gets confusing, what's one or the other, right? So pre-processing applies to all of your images in training and inference to assure images are formatted correctly for your model and context, okay? So every image in your set, that's what it applies to. And you're trying to ensure the format is correct. Augmentation only applies to the training set, and it increases the size of the training set to improve model fit, often reducing overfitting. And I'll show that in a second, in a couple of minutes. But with augmentation, you're creating new images, right? Essentially synthetic images, as opposed to pre-processing, where you're doing it to your existing data set. All right, training the model. So training on Amazon Rekognition custom labels. So training a model relies on selecting a good model architecture for your problem, right? It's all about the problem, the use case. So generally, this is a selection process based on the deployment conditions, right? So it could be on device, it could be in the cloud, it could be, time of inference might be extremely important. So in our example today, we will assume a server-side model deployment and leverage Rekognition custom labels, as I mentioned, to do the model selection and one-click training for us. So when you're dealing with, you have, as I mentioned a little bit further to that, things that you have to factor in what's important, right? Is accuracy the most important? Is speed of inference the most important? The size of the model, right? So all things that come into play. Now here's just a screen grab of what Rekognition custom labels looks like, and I'll show it, live in a couple minutes here. But it's a very easy service to use. I mean, it's a bit of a pain if you're doing manual stuff where you have to actually go into the UI and you have to crop bounding boxes yourself on things. So maybe I wouldn't recommend it to do the labeling. It does have the ability to do that, but as you can see there, start labeling. So you do have the ability to do labeling. It's just a bit painful and very manual. So we're not doing labeling in this today, but we use SageMaker ground truth labeling for this use case. Okay, now inference. So how we plan to use our model determines on how you'll bring it to production. So again, a little bit further to what I said, example, embedded devices, imagine those on a factory line. We'll have a device running on factory machines, right? So it could be a camera on a factory machine. So that, that's embedded, right? Server-side inference means you need to call an API. And Rekognition custom labels, that's what they do, right? They provide an API and you can just, you hit that from your application. All right, so let me just stop sharing here for a second. And let me just bring up. All right. Okay, so I hope everyone can see my screen with the Roboflow dashboard up.
Absolutely.
Perfect. Okay, so this is the Roboflow dashboard, okay? And I'll walk through creating a data set within Roboflow and go through some of the things that you can accomplish within Roboflow to get your data, kind of up to snuff here. So let's call it, let's say, we're going to be doing object detection, as I said. Let's just call it mask. Okay, we'll create the data set. Okay, so I already have the data set. So here, what I'm dropping in here is the folder that is the output from ground truth. So this is SageMaker ground truth output, which is all the images, and that manifest.json, which is the annotations that are associated with anything with ground truth. Let's just drop that in here. So right here, Roboflow is doing a series of checks, right? For example, they're looking for anything that's out of frame or anything that has a 0 pixel annotation, something like that, right? So they're doing a series of checks as it loads in the data. You can also see that it's showing you, the images and what's annotated. So, if you had a bunch of images with no annotations or labels, then it would come up here and show you, like they're not labeled. Like if you had a set of 50, maybe pull them out at that point, things like that. Oh, here you go. So there is an image with no annotation. So there you go. There's a good example. All right. So as you can see, all the images are loaded. Now this is reading the labeling and images from ground truth, as I mentioned. So now I can just go here to finish upload. And as you can see here, you have the ability within Roboflow to do the split, right? You can do a train, the validation test split. You can add all to the training set, all to the validation set, all to a testing set. So something that's pretty cool. Now from here, I'm just going to do this split. This is probably going to take a couple minutes. So, I mean, feel free to ask any questions as we wait the 2 minutes to get this accomplished. Oh, now it's a minute. We're flying today.
Now is a great time to share questions that people have in the chat. I see that there's a couple of questions that have popped up. Bernardo has shared what he's working on using YOLO V5 for his startup in Brazil, which is awesome to see. I mean, Mark, you got to add it to the use cases slide you showed us earlier.
Yep.
Michelle reaches out and asks, will the model and data set to be available to public in the future? Absolutely. I will post the links to both of those things here, and I will be sure to follow up. As I mentioned, those that complete our survey at the end will have first access to the recording and all materials to reproduce exactly what Mark is doing today. We have another new question, a great question. So Rakesh says, I believe the split would handle class imbalance question. using some sort of stratified split. So what Rakesh is getting at, so for example, let's imagine that we had a class that was severely underrepresented, right? Let's say we had, we had people with masks, people without masks, and people wearing masks incorrectly. And like in theory, let's say that people wearing masks incorrectly are only 10 images, right? Well, we would want to make sure we have some of that representation in the training, valid, and test set. Today, the type of train test split that happens is completely random on the way the images are uploaded. However, as Mark demonstrated, you could actually upload images and specify if you wanted to only add them to validation or testing. So if you already knew, hey, you know what, I have an underrepresented class, I want to be sure that only some of these images are in the training set and only some of these images are in the validation set, that is supported based on doing that upload. All right, one more question. I want to train my monkey data set on YOLO v5 PyTorch. How can I handle it? I will share a link specific to that question. This monkey data set has got me wondering what you are working on. Minimum, how many images required to train a good model? You know what, Mark? That's actually a great segue to what you're probably going to take us through next. So I'm going to hand it back to you.
Perfect. So everything's uploaded now. So as you can see, I have my data set here. Annika masks. I have my split as I defined it when I did the upload. We'll take a quick look here. This is something within Roboflow that's pretty cool. You have the ability to check your data set health check, right? So you have the ability to see the amount of images, how many annotations you have, the average image size, the median image ratio, right? And then as you can see, a class balance. So here, this is a common problem where you may have people that have labeled it with mask, and some other people may have labeled it mask, right? So that's the same thing, but obviously it's reading the class and it's imbalanced, right? So we're going to fix that up. So we have the ability to do that within Roboflow. Then as you can see, we have some dimension insights, right? So it integrates the medium width by medium height per image, right? Some more aspect ratio stuff. Then we have a heat map, right? So you have the ability to see your mask, no mask, mask where incorrect, without mask, right? With mask. So, some pretty cool things you can do and check from within the dataset health check. So let me just go back here. Let's see here. Okay, so what we'll do first is we will add some pre-processing steps. Let's do that, okay? So a little bit more to what we mentioned before. So you have your pre-processing options. So you could do a static crop, you could do it a grayscale, you can do auto adjust the contrast, right? You can split it up into tile, you can modify classes. So let's do that. Okay, so we're gonna override that. So mask is gonna be mask. Let's do that. Let's just do mask and no mask. So mask wear it incorrectly, well, we're just gonna say mask because they're wearing a mask, okay? No mask, we'll keep no mask. With mask will be mask. There you go. Without mask will be no mask. Okay, apply. So let's add another step. So maybe we want to, actually, let's just close that. We already have a resize here. So this is the ability to resize. So we'll keep it at a stretch 416 over 416, but this is probably something it's one of the top, pre-processing options that you could do. You have the ability to fill, fit within, stretch, then you can fit white edges, black edges, etc. Okay. All right. Now we'll do a little bit of augmentation. So here's the augmentation options from within the platform. So you have, flip, these are the things I already mentioned, 90% rotate, 90-degree rotate, crop, rotation, shear, brightness, right? So lots of things you can do, and that's on the image level and then the bounding box level as well. So let's do some brightness. Sure, 25% is good. Okay. And then let's do let's do a crop. We'll keep it at 20%, sure. And again, as you can see here, after I added the augmentation step, you see the augmentation output, okay? So for each image in your training set, how many augmented versions do you want to generate? So you can go up to 50. You can go up to 50, but we'll keep it at 3. So what I'm doing is I'm taking my images that were 997, or in the training case 698. We're upping that now, right? So we're creating synthetic images that are augmented to add to be able to better train your model. So we're going to go up to 2393 in images. So let's do that. Generate here. Let's just name it. So we're generating right now. There was actually another augmentation that I wanted to mention. It was Mosaic. That was actually new in YOLO v4 from, I think it was April. So it adds a mosaic, right? Like a window pane to your image, right? Something cool and it's fairly new. So I just wanted to call that out. So this should just take a couple seconds. So what you'll see here is it's going to generate a version. Okay, I'll just close this for now. But it's going to generate a version, right? So I now have a version which you can use, to collaborate with other team members. It doesn't do anything to the original data set. That's all still here, 997 images, right? It shows 2393 after augmentation. So here's my version, right? It's got everything done that we asked it to do, right? The crop has been done, some brightness, 3 times the amount per one image. It's got the pre-processing steps. And then actually here, you have some stuff for ready to train. So here you have the ability to download your data set, export your data set, right? So this is the different formats that you can grab out of it. So you can grab, YOLO v4, v5 PyTorch. You can grab Pascal Bach. You can grab Coco, right? So even though originally what was put into this was manifest.json, which is an AWS specific thing for ground truth, you have the ability now to transform it to anything, any of the more popular things that can be used outside of AWS. So if you want to export your data set and you want to take that over to Google Colab and you want to train your own PyTorch model or your own TensorFlow model, then you would just download it, as a TensorFlow object detection, for example, or a TF record. Okay, so something really cool. And you can also, you don't have to download it. You can also get a link, so you can just hit that link from within your notebook. Also, something fairly new, I believe it is. Joseph, I don't know if you want to talk more about that, the Roboflow train.
Happily, yeah. So, I mean, we actually had a question in the chat from Carlos about this. Carlos was like, will Mark really have time to create a neural network from scratch? And the answer is, well, not really, but he also doesn't have to. So there's levels of abstraction to write in a model, right? Just like in traditional software programming, you could, in theory, get in and write some assembly code, right? Or you could get like one level higher and maybe use a language like Java, which might be a mix, it's generally higher level, or even yet higher level than that might be a language like Python, which abstracts garbage collection and some things like that. Or you could even, in theory, get a level higher than that and use something like Webflow, which has a blended mix of writing code and having a graphical user interface. Doing machine learning isn't so different. And actually, Roboflow supports whatever level of depth you would want to go into. So Mark showed you could export your data set in the correct annotation format for, say, using TensorFlow and then writing your own model from scratch in TensorFlow if you wanted. Roboflow actually has a set of neural network architectures with the source code available at models.roboflow.ai if you want to start with an existing base network. Or you could go one level of abstraction higher, like we like to call it the impatient developer, where you want a model that works and you want to do one-click managed training, scales up, picks the architecture that works best for your problem, and sends back an API. And that's what these services are. So Roboflow Train does that with a one-click from any Roboflow account. Then you could also use, we play nice with other cloud services. We understand that whatever choice is best for your data depends on what is the relevant context for your problem. So Mark, being an AWS expert, is going to show using ground truth, the AWS Rekognition, custom labels, the AWS Rekognition product for doing one-click training. But the truth is the level of abstraction kind of depends on what level of need you have. So Roboflow Train in our benchmarking trains faster and as accurately, if not more accurately, than a lot of these services. It kind of depends on the problem type. But really what we're after is making it as easy as possible to support what you want to do. If you want the quote unquote lazy developer, and no shame, I do that all the time too, even though I could write a network from scratch. Sometimes I don't need to do that. Then you do Roboflow Train. If you have a specific cloud architecture, you go that direction. If you want the source code, you can go that direction. So yeah, Mark, I'll let you go on back into our training progress.
Perfect. Yeah, and I mean, further to that, I'll just mention, it was a while back, a few months back. I was able to, grab another data set. It was a hard hat data set. I was able to run it through Roboflow, get it in a good format. I think I converted it to Cocoa, right? That's actually how I found Roboflow, because I was trying to do that, writing scripts, writing code, and convert from Cocoa, or from Pascal to Cocoa. And then I was able to, when I found Roboflow, I was able to do it in a matter of minutes, as opposed to me writing a script and doing it. And then, I was able to, I don't know if anyone's heard of Detectron 2, but it's a popular, I believe it's Facebook, Detectron 2, backed by PyTorch. And I was able to, train a great object detection model in a matter of hours. I think actually putting together the notebook itself, which was already pre-built from Detectron, was like an hour, and then making some tweaks, and then training my model might have took maybe 4 or 6 hours after that, because there was a ton of images. But I mean, yeah, I didn't have to write anything from scratch, and I was able to do it no problem. So just so you know, you can go out there and do it. You don't have to be a machine learning expert to do this stuff, right? So something worth mentioning. All right, so as you can see here, I click AWS, okay? So what it's doing here, Roboflow has, it's my account, it has my access keys, my AWS access keys. So what it's doing here is it's going in to a user that I've gave it to create an S3 bucket, and it's pumping the data into Rekognition, it's pumping the data back into S3 in the manifest.json format, which is what Rekognition expects, okay? So as you can see here, I've got my training dataset link. So this bucket would have been created in my AWS account, and this would be my test dataset, right? So .manifest. So if I just open this in a new tab, okay, so this is my Rekognition custom labels screen, okay? Let's go back here, let's copy this. Let me create a project, and we'll call this test. Okay, let's create that project. Data sets, let's create a data set. Okay, so as you see, I just went to data sets, create data set. I mean, Rekognition custom labels is extremely, point and click. It's extremely easy to use. So let's call this data set mask 2, because I think I already have one called mask. But and then we're going to select, import images labeled by Amazon SageMaker ground truth. So at this point, it knows to look for that .manifest file. And here, I just throw in, we'll show it again, the training S3 bucket URL for that file. Copy that in here. Make sure your S3 bucket is configured correctly. And upon, behind the scenes, when Roboflow creates this bucket for me, as it goes into my AWS account with my access keys, it adds this policy to the bucket. So I'm going to submit that. Okay, so there is that. So all my images are now in here. They're all in Rekognition custom labels. And I can simply click train model, okay? So I'm going to select that data set, mask 2. And then now it's saying, okay, do you want to split your data set? Do you want to create a new test data set, or do you want to choose an existing? Okay. So in this case, I'm going to create a new test data set because Roboflow has already done that split for me. Okay. So now it's saying you have to create a new test data set before you can move forward and train, which is fine. Continue. So we'll call this mask test 2. Okay. We're going to do the same thing, import images from SageMaker ground truth. Let's go back here. Let's take that second link, right? This is your test link. Back. We're going to do the exact same thing we just did. Same, warning comes up, make sure it has that policy, which it does. Submit. Okay, so let's bring that up. Okay. So now I'm going to go to my data sets. I'm going to go to my mask 2 data set. So this is my training data set, and I'm going to click train model. Okay. You have to select the project, which is why I did that first. We'll call it, that was the test webinar. Now here, my training data set is mask 2. My test data set, I'm going to choose an existing one this time. and it's going to be called Mask Test 2 and Train. That is it. That is it. And to show you a couple things, this is going to take a while, to be honest with you. I already did it. It takes a few hours to train. I mean, there's 3,000 images or so. So it does take a little bit of time, but I mean, you just sit back and wait. There's nothing else to this right now. And then if you go in, I have another project done right here where you can see exactly what I did there. This is the train model. So this is the endpoint. This is showing the training data set information. I just did the exact same thing I did here. I just wanted to do it earlier to have a trained model to showcase training completed. It's got the performance here too. The status, the model's ready to run. It shows some information about where those data sets reside. Okay. So, and then at this point, let me stop sharing here. Let me turn off my video because I don't think I'd be able to do this with my video on. And now we'll take a quick look at what this looks like live. Live demos, I like them. All right, so let me see this. Now if I share my screen, all right, hopefully everyone can see. Can you see my screen with me and the no mask?
We sure can.
All right, so let's bust out a mask. Make sure I put it on right. Oh, there you go. As soon as you see it, just take my headphones off for a second. Showing the mask.
Headphones
Okay,
extra
take it
challenge.
off. No mask, mask. Let's do a partial. Nope, I'm tricking it a bit. But as you can see, mask, no mask, mask, no mask. It's actually, I think the headphones are confusing. Hold on a second. All right, pretty cool. Anyways, it's probably enough showcasing. And you guys can visit this link. I think it was in the webinar, invite. Would that be right, Joseph? I think so.
That is right. Yeah.
Yeah. So I mean, it's probably that is simply a front end app that was built. Joseph built that app. And I mean, Joseph, you can speak to more about how you built it, but I mean, all that's doing is hitting the Rekognition custom labels API, right? That's all it's doing. So
Awesome. Yeah.
cool. Let me go back to sharing for a second.
Yeah, you got some wrap up in the deck.
Yes,
And
I do.
we've been doing questions throughout. We've had about, I don't know, 5-10 questions streaming throughout. So welcome the continued participation from folks. It's remarkable. We've had strong attendance from start to end. And yeah, Mark, provide some takeaways here. Drop some last questions if you are attending and you have additional last thoughts. This is your chance to speak to experts in the space for working on these types of problems. So please drop your questions. And Mark, go ahead and share with us. If I'm interested and I like what's happening here and I want to do more, what do I do?
Yeah, I mean, quickly, I'll just go over how you can engage with us, right? Custom AI/ML solutions. So Aunica can build, AI/ML solutions for any size customer or application. It could be a proof of concept all the way to full production workloads. These are built on and with AWS, of course, right? Because we are an AWS-focused partner, leveraging powerful capabilities that can scale to any business need. Solutions may include certain things like AI services from within AWS, right, which Rekognition falls in, but there's also things like Textract, which is an OCR tool. I don't know if anyone's heard of that. Poly, which is text to speech. Transcribe, which is speech to text. Comprehend, which is NLU NLP service. Amazon Lex, which is one of my favorite AWS services, which is conversational chatbots. As well as ML tools such as Amazon SageMaker, which we touched on a bit. We didn't touch really on SageMaker. We touched on Ground Truth, but SageMaker is AWS's end-to-end machine learning platform. as well as, we have a full suite of data scientists on staff that can help, with certain things from the framework level, right? Start, from TensorFlow models, PyTorch, any of that stuff, right? All the way up. So as you can see on the screen, we have a few kind of common engagement models where, ideation session is one. Actually, even before ideation session, we do like AI/ML workshops. So it's like a high level day of learning about AI/ML end to end. We can start off at any level you want and go all the way up to detailed, 100 to 400 level, whatever that looks like. So that's something that we also offer. Ideation session, which is kind of tailored to your specific needs for certain things. That could be, return on investment, value for your business, whatever you're trying to accomplish there. And that's instructor-led, kind of a lab format. Then POCs and pilots, right? So you may already know what you want to do, so we can start with an MVP, a minimal viable product, or a POC, proof of concept, to put your plan right into place, test out that theory, get that value test the value of that use case. Generally, these are POCs are scoped to about 6 weeks effort. Or right into production. Maybe you already know what you're trying to do. You already have framed it. You've already played with it in-house, but maybe you just don't have the skill set in-house to take it over to that production level. We have full production solutions to automate business workflows, develop actionable predictions, any of that stuff. One thing I love to mention is getting a machine learning model or a deep learning model out of the development stage and into a production stage is extremely difficult. 60% of machine learning models never even make it into production. They just sit in a dev account to die, really. So so we can help with that. And that's all I wanted to say there. And also on this slide here, complete our 5-minute survey. There's the link, or you can scan the QR code right now. Your chance to win $100 in AWS credits. So who wouldn't want that? So please do fill out the survey. Let us know how we did. And thanks for the time. I appreciate it. And thanks.
Awesome. We will give folks a moment to complete the survey here. I will also drop the link in the chat as I'm typing away Annika Roboflow. So please, it's really a 5-minute survey, honestly, probably shorter than that. It's the opportunity to basically share with us what your project is, if it'd be useful to engage with Annika, if it's useful to use Roboflow to accelerate your development, or if not, frankly. The other thing we're interested in knowing is how you found the value of today's content. Good feedback means we'll do more of them. Bad feedback means we'll improve. So let us know what we can do to improve your experience. I'm going to continue to answer a couple of questions that we have here in the chat. Mark, I'll go ahead and just do that verbally while we have folks completing the survey. So
Yeah, absolutely.
The last question we had here, the most recent, I should say, does Roboflow offer a tool for labeling images, or this has to be done in another tool? So Roboflow today supports a wide array. I mentioned 30 plus annotation formats. So you can label in tools like CVAT or Microsoft Vought. I'll drop a link to CVAT, which is a free tool for getting things labeled. And then you export your labels and import them to Roboflow with ease. And if you would like to use a managed labeling service, like you say, oh man, you know what? I know how to label this data. I now just need to scale up my labeling. That's where you use AWS Ground Truth to scale up your labeling job. It's like bounding box detection. But yeah, the ease of use of basically use whatever tool is your favorite, and we'll support that annotation format as long as it is a standard one, and have your data cleaned up, prepared, and ready to go. Just as Mark showed today, you had to correct that problem where you had 4 different classes, but really all you wanted was 2: mask worn, mask not worn. And you actually even saw the model get a little bit confused when Mark had his mask worn incorrectly. We labeled that as having a mask, and so the model kind of learned that was the case here. All right, we have another question. In doing real-time application, do I need to pre-process the images, resize, remove EXIF, etc., before the inference, or can I just feed it directly into the model? Gustavo, fantastic question. So, for example, let's say you do a resize decision for your training process, and now you're putting your model into production. Do you have to resize your images before you use that model in production? The answer is yes. Those pre-processing steps are what enable you to have your model learn the consistent size, format, etc. So for example, if you resize your images, remember Mark showed us resize of a stretching of the pixels or a preserving aspect ratio of the pixels, the model is going to learn whichever aspect ratio we taught it on. So if we pretend to have stretched all of our images in a specific way, we should stretch those images in the same way in production. Now, Roboflow actually has a Python utility on the way where you can easily use that Python library to pre-process your images with 3 lines of code: roboflow.load, roboflow.auth, roboflow.preprocess. And we will pre-process the images in your training pipeline, because pre-processing is required for training, validation, and test. Augmentation is only needed for your training images to increase variance, etc. Great question, Gustavo. All right, any last questions in our final minute here? And yeah, Mark jumped in on the chat. He said, Monica, you can skip the ground truth piece. He's right. If you already have things labeled, whoop, just go ahead and get those images into Roboflow with your labels, start to clean, organize, prepare with your team, and start training, whether that be a one-click training using the Roboflow model library, or maybe you have your own model architecture like Carlos was mentioning earlier. This is the thing that he wanted to get after. Any last questions before we wrap? Awesome. So, okay, here's what happens next. Those that have completed the survey get first access to Lorenzo, integration with Amazon EC2. Yes, you can scale your training on Amazon EC2 using any code that you already have set up. We're happy to do that. What would be the next webinar? Love that question. We will let you know. We will update anyone that is on our newsletter or the Annika newsletter for updates on what we can do next. Really appreciate the enthusiasm. Please do complete the survey. As I mentioned, if you complete the survey, you are entered to win $100 in AWS credits they could use on ground truth, training with custom labels, or otherwise. Okay, so with that, Mark, any last thoughts before we conclude?
No, I'll just say, further to the when's the next webinar, specifically for myself, I have a webinar. I'm giving a webinar next week, Monday, I believe, on Amazon Kendra. So I don't know if it's a new service from AWS. It's an AI service. It's NLU, NLP alternate to Elasticsearch. So I'm doing that. Also, right before this, I was recording a podcast, and that will be out in a couple of weeks. And that is on data-driven decisions to reopening in the times of COVID. How businesses can make the right decisions, without seeing all the mess and bias that's out there in the media, social media, news, and actually looking at the data to make a decision on when to reopen their offices. So a little shout out there.
I'm signed up. Mark, I'm drawn in. Like a firefly to a bug zapper, your talks. Cool. So thank you so much. I see you, CE. It's great to see you again. I know we spoke maybe 2-3 months ago now. It's great to hear that you've made progress in your project. Can't wait to accelerate your development with everything that we have new to show.
So I'll just say from CE's question, OCR, specifically, that's Amazon Textract. I gave a webinar on that a few months ago. So if you could, you can dig that up on Bright Talk CE. I did a webinar on Amazon Textract and the ability to use that AI service from within AWS to, use as a new OCR tool, pull out forms, tables from images, run them through a pipeline. So check that out. That's on Bright Talk. Just search my name or Annika.
Boom. Thank you, Mark.
Yeah.
Awesome, CE, and everyone. Thank you all for joining. We really appreciate the engagement. In fact, we had steady, equal participation throughout the entire webinar, which is rare that people are so drawn in and engaged. Can't wait to see you on the next one. Those that completed the survey, you will get access to our materials first. Thanks for joining us. See you next time. Thank you.
Thanks, everyone.